Today, I'd like to share with you an exciting new product, ArcGIS Image for ArcGIS Online. This new offering allows users to host, manage, visualize, analyze, share, and collaborate imagery content all within ArcGIS Online as a software as a service. To demonstrate this, we'll explore the country of Grenada, located in the West Indies and the Caribbean Sea. Grenada is currently working on updating its GIS with new content, such as aerial imagery, elevation layers, and LiDAR data. Using ArcGIS Image for ArcGIS Online, let's see how we can do this. We'll begin by uploading some imagery data. Imagery layers can now be hosted as a static tiled imagery layer for efficient viewing and optimal analysis performance, whereas a dynamic imagery layer that supports dynamic mosaicing and on-the-fly server-side processing. By following the user interface, we can select a layer configuration and choose a raster type. Raster types makes it easy to build imagery layer from a variety of raster formats and providers. We'll be using GeoTIFFs, so we'll select raster dataset. By simply dragging and dropping aerial imagery collected by our partner Fugro, the data will now be created in ArcGIS Online as a dynamic imagery layer. Let's take a look at the layer we created. This is 60 gigabytes of aerial imagery provided by the government of Grenada and supplied by the United Kingdom government, all hosted in the cloud as a service in less than 10 minutes. This high-resolution orthomosaic image provides a crisp, recent view of the entire nation. Zooming in, we can see more details, like this cricket stadium. A dynamic imagery layer like this provides access to all the pixel values, metadata for each image, and applies on-the-fly server-side processing, which returns only what is required to display on the screen. For example, we can change the band combination to false color to better understand the surrounding area. Now we can easily identify this quarry next to the stadium. Let's switch back to natural color. Now that we have our imagery data hosted in the cloud, we can perform additional feature extraction to build our foundational data layers. Digitizing features like this used to be a tedious task that took long hours of manual labor. Now we can expedite and automate this process by leveraging deep learning. ArcGIS Image for ArcGIS Online comes with a collection of raster analysis tools, which includes object detection. From this tool, we can use either a tiled or dynamic imagery layer as our input and select a model. Training and curating a model can be a challenging task, especially if you've never done it before. The Living Atlas provides a library of deep learning models that work seamlessly within ArcGIS Online. You can access these models that vary from extracting features like building footprints, classifying land cover, and many more. With the building footprint extraction model selected, we can now run the tool and get our results for the entire island. Here are the results from some of the deep learning packages done in less than a day. 55,000 building footprints, roads across the island, and a complete land cover classification layer. These are just some of the capabilities available in ArcGIS Image for ArcGIS Online. To take a deeper dive with more advanced raster analytics, I'd like to hand it over to my colleague, Kate Hess.
Now that Yoon has created foundational GIS layers for the country and hosted them in the cloud, I can easily access the data remotely. I'll tackle our next challenge using the power of raster analytics in ArcGIS Online. Grenada has rugged topography and faces frequent tropical storms. As a result, they regularly experience landslides, which can damage homes and businesses, disrupt transportation, and even lead to injuries and death. Let's identify infrastructure that may be at risk by using a process model to proactively locate areas susceptible to landslides. We'll perform this analysis using tiled imagery layers hosted in ArcGIS Online, including our land cover classified from Imagery, the digital terrain model, the soil types, and the distance to river features. We're going to calculate landslide susceptibility from these layers using raster functions, all within the map viewer in ArcGIS Online. The Analysis tab gives me access to the raster function editor, which we'll use to create our image analysis process model. Here, I have access to more than 150 raster functions out of the box, including mathematical operators, geometric functions, and radiometric functions. These can be chained together to create new raster function templates for more complex operations, like my landslide susceptibility workflow. This processing chain takes in the 4 layers in our map and normalizes them to a common value range, then takes a weighted sum to identify the areas susceptible to landslides. Let's zoom in to evaluate a preview of our results. Previewing the analysis before running the model allows us to gauge if the result looks reasonable, or if we need to make adjustments to our input variables or to the weighting in our raster function. In the preview, we can see in red the areas at high risk, and the areas least likely to see a landslide are in dark green. When we're happy with our model, we can run our final analysis to get a persisted product. This analysis in ArcGIS Online takes only 1 minute and 30 seconds, so let's jump ahead to the output. Now we can see the areas with high susceptibility to landslides for the entire island. Let's bring this output layer into a 3D scene so we can visually explore the relationship between landslide risk and elevation. In 3D, I can clearly see how slope steepness relates to landslide susceptibility. Let's get a better understanding of what infrastructure may be at risk by bringing in the building footprints and roads that Yoon extracted from Imagery. These layers are easily accessible to us since they're hosted in our organization in ArcGIS Online. In 2D, we can clearly see that this building falls within a high-risk area. But now in 3D, my attention is also drawn to this road, which falls within an orange area, but would be impassable if there were any significant landslide above it on the hillside. This is just the beginning of what we can do with hosted imagery layers and deep learning models in ArcGIS Image for ArcGIS Online. All of this was created in the cloud, so we didn't need to set up any infrastructure to run our analysis. We can also use point cloud data and ArcGIS Pro to bring our buildings into 3D. This gives us additional context for the building on the slope, as we can now see its height and shape, and how much of the structure is built on the hillside. With the additional capabilities of ArcGIS, we can continue to build out our countrywide database and foundational GIS, including bringing in LiDAR data to see our vegetation and power lines. We now have a 3D base map for the entire country. As a result, we have a building inventory for census planning. With the additional data layers, we can have an approach to natural disaster response that is more data-driven. And urban development, like here in St. George, can be intentionally planned and sustainable. All these capabilities, hosting imagery, deep learning models to extract features, and sophisticated raster analytics, are now available in the cloud.